All right, before we get started, I'll talk to you a little bit about what a binary file is. We've done text files back in intro, hopefully. A text file is something you can open up and all of the data is interpreted as characters from the ASCII table, or maybe even from Unicode. Everything can be interpreted as a character. When you're doing a binary file, everything is stored as if the file was a chunk of memory itself. Okay, so we're looking at the bits and the bytes, and all of that just gets copied into a file. And then whenever you turn your computer off, that information is stored on your hard drive. You can turn the computer back on and reload everything that your program already had. And so the advantage of a binary file is they're usually smaller. They can be quicker to write. So if I've got a really large structure here with, I don't know, a dozen or more primitives in it, I can just save that structure to a file, and then I can load it back up later, and that works just fine, and it's a whole lot faster than saving it as text and then loading the text back in and then reinterpreting the text to be integers and floats. You get what I'm saying? We can save an object to a file is what this allows us to do. But it's also a little bit complicated or it can get complicated real quick, because you have things in your objects like strings, and you have arrays, and arrays are not too bad, but you have pointers, right? And when you save a pointer, what are you saving? An address. So when you turn your computer off and turn it back on, or even restart the program, and you load that address back up, is it going to have the data there that you expect or that you want? No, that address is probably almost guaranteed to have something totally different. So your pointers, you have to deal with those separately. And dealing with strings and stuff like that are storing, a string as an object has a character array in it, but it also has some other stuff. And so when you save a string object, what you get is a little bit weird, and it doesn't always load back up the way you would expect it to. So binary files are great for storing primitives, and they can do it real fast. You can store an object real quick and load it back up real quick. But when you start getting complicated, start working with pointers and stuff, it becomes awkward and maybe not even worth it in some cases. So some people say don't do it at all, but it does have its place. So we'll just look at that. I've got two structures, or I got a structure and a class set up here. We're going to put some primitives in there and see if we can save and load this stuff. I'm going to erase the file I created yesterday just so it doesn't get in the way. We're all starting on the same page here. One of the things you want to include is fstream up at the top. That's the same as if you were using a text file. So don't forget that. And let's start with the weapon structure here. We'll just give this guy some parameters like a damage and a attack speed. And we can go down here to the hero and give him a name and a class. Hit points. I don't know, you can put more stuff in there if you want to, just something. But let's see, with just a few primitives up here, let's see if we can do, I'll do one more. Let's see if we can create a weapon and then save that weapon to a file, restart our program, load that file back up, and see if all of our data is still there. So if we're going to create a weapon, we'll do this simple weapon on the stack here. We don't have a constructor. I'll tell you what, let's put in a constructor. Recognize your values here. When we load this thing back in, we want to know if it has these values or other values that we're going to save. So we create the weapon here. It will have these values. Let's go ahead and write a display method so we can check this stuff out and make sure it's doing what we think it's doing. And just to test this out, down in main we create our weapon and we'll call display against it. All right, and you should see this information from our constructor, our default values there. It's kind of ugly. There we go, that's a little better. But let's change the values. So those will be our default values. And just change these to something different. And we're going to try to save this to a binary file, and then we're going to load it back up and we're going to check the values again, and we're going to see if we get default values or if we get the values that we saved. All right, so to create a binary file, we're going to have an OF stream, and we'll normally just call this out. You can call it whatever you want though. And it's going to take the name of your file. This can also be whatever you want. Now typically a binary file is called a .bin, short for binary, or a .dat, short for data. But you can call it whatever you want. I wouldn't call it text or exe or anything, but bin or data is pretty normal. And then we're going to tell it what mode we want to open in. So we're doing iOS binary. And then you normally OR that with out. And next, we can write to this file using the write method. And when you're writing a binary file, you're going to give it an address. You're going to say, hey, go to the memory right here and start writing. And you tell it how far you want to go, how many bytes. What is a byte? I'm not talking about cookies. I'm talking about digital information. What's a bit?
A bit is a single byte.
If a byte is a bit, then why would we have two different words for it? A bit is a 1 or a 0. So what's a byte? 8 bits is 1 byte. What's a nibble?
It's delicious.
No, we're still not talking about cookies. A nibble's 4 bits. Not used very much other than one of those things you can say, hey, I know what a nibble is. Might show up on an interview. Yeah, a byte is 8 bits. It's 8 ones and zeros. How many values can you represent with 1 byte? I'll give you a hint. 1 bit can represent two values, 1 or 0. If you've got 2 bits, you can represent 4 values, 0, 0, 0, 1, 1, 0, 1, 1. So 1 byte, how many values? 4. We got 4 with 2 bits. We got 8 bits in a byte. Do you think? To the power of 8? 256. It doubles every time. Every time you add a bit, it doubles. Right? Because you got all the values, and then you got all the values flipped. You start with 2, you go to 4, 8, 16. By the time you get to 8, you'll have 256. Anyways, you're going to tell it how many bytes you want. You're going to give it a starting address. You're going to tell it how many bytes you want to cover, and it's going to start at that address and go that many bytes over, and it's going to write that to the file. So this is how we do this. How do we represent a byte in C++? Char is a byte. We need the address though, so it'll be a char pointer. And what are we saving here? We're saving our weapon. So we'll start at the address of our weapon. You'll understand this. I am casting the address of my weapon as a byte address. So start here and go for how far? Well, we have a size of function that will figure that out for us if we're being lazy. So you just tell it, hey, check out the size of my weapon. That's how far you're going to write. So write that in there, and then we can close the file. And run this program. Now when you write a file, if this file does not exist, it will be created. So now if you right click on your project and then click Open Folder in File Explorer, you should be able to see your save.bin there, or whatever you called it. And you can open this up and look at it. Now if it doesn't pull up in Notepad, you'll have to tell it, hey, use Notepad. But notice there's some information in here, but it's not my weapon information, or at least it doesn't look like it. See, Notepad is trying to interpret those 1s and 0s as just characters. But they're not characters. They're floats and integers. And so that's what I got. And so for better or worse, the binary files are somewhat encrypted. All right, but to see if this worked properly, what we need to do is load up that file. And loading is a lot like writing. You're going to do an IF stream. So we're coming in. We're going to load in that same file. We're going to have our same flags, binary. Well, then, of course, we're going in. By the way, you can do these in 2 lines if you want to. You can declare your object as an in and then do in.open and put this stuff on there. You may see it done that way. But there is a constructor that allows you to do it all at once, so that's typically the way I do it. But if your file objects are part of a class or something, you'll have to declare them there and then use the .open to actually open the file. All right, so we've opened this up, and we'll do a read. Read instead of write, and this works the same way. You just tell it, where do you want to write this information, or where do you want to load this information? It needs an address, so it comes in as a char pointer, and you give it the address of wherever you want to put that information. Now you have to have memory allocated for this object. The thing. You can't just say, hey, write this wherever, anywhere in memory you want to. You have to tell it where. So we'll need an address that is capable of holding a weapon. So what I like to do is just go up here and create a weapon. And we'll call it weapon 2. That's going to invoke our default constructor here. So if our load fails, we'll get default values when we call display. But if it works correctly, we'll get the values from this guy right here. So we give it the address of weapon 2. And same thing, how big, size of. If you haven't loaded it in yet, you may not know how big it is. So you can put weapon 2 here, or you can just give it the class name. And that should work. That'll read it in. We can close that. And then we will call display on weapon 2. Now, before I run this, I'm going to comment out all of this stuff. Okay? So now I'm banking on loading from my file instead of anything from running the program. All right, now if I get default values, I know I did something wrong, but if I get these values that I set up above, then my load and my save are working properly. All right, so I did get my values that I saved. That means it's working properly, nothing crashed. So this is all really good. Does everyone understand how this works? It's not too complicated. You tell it start at an address, and read or write, and then you tell it how far, how many bytes. And as long as you are working with really simple primitive data, this works just fine. But let's get complicated. Let's get the hero in the game here. We'll give hero a constructor. Give him some default values. We'll give him a display method, all that good stuff. So What's a good class?
Warrior.
Classic. And some hit points, default hit points. All right, we'll give him a weapon in a little bit, but right now we'll just handle the complication that comes with using strings and binary files. All right, I'm going to comment this out for now, everything that we already did, and basically rewrite it as a hero. Oh, we need a display method for the hero. I need to put inlines on these. All right, so down in main, we'll create a hero. Oh, I didn't do his hit points. All right, we'll create the hero, and then we'll save. You can call display on it if you want to. I'm confident it works just fine. But to save this, we'll need to open our out string. And we'll call write. We pass it the address of the hero, and we pass it the size of the hero. And then close. So once you get that, go ahead and run it. Nothing should happen, but it should update that file to contain hero information. And now I called it dat instead of bin. I don't know why I did that.
You
It doesn't matter. You're just going to have to tell Notepad that it has to read. It's going to have to read the DAT files as well as the bin files. It doesn't matter. It's just out of convenience. Okay, so I open this up and I look in here and I've got stuff from my default constructor, but I've also got some weird stuff in here as well. So let's just load it up and see what happens. I got to create a space. Actually, I need to change the values, right? If I want to see if this actually works. So the name will have to be different. I'll run that again. Okay, it looks different now. But it looks like it's definitely saving my information. Let's see if we can load it. So we create a space for the data. We open an input stream. We're going to load from save.bin in binary. I don't know if you have to put this flag on there for in or out. It seems really redundant, but it's normally done, so I do it. And the in.read, read in as a char pointer. The address is hero 2. That's where we put it. And the size of a hero. It's how much space we're going to read. And then we'll close that file. And we'll call display on hero 2. Okay, and it crashes. And this is what happens when you start working with strings in binary files. But the output is not bad. It even ran the whole program. Doesn't crash until the end. I got my whole string in here. And so it kind of works, but it also kind of doesn't, because it crashes at the end. What? You did it wrong.
Oh, that's why.
I'm going to comment this out so that it has to read from the file.
Mine didn't crash out.
Doesn't crash at the end with this null pointer exception?
No, did you,
Or read access violation?
no. You used the same name for out and in, right?
I use the same what?
Did you? Yeah. You, oh yeah, you did. What are the differences?
I'm gonna scrap all of that. So you have exact same thing as me and yours did not crash.
Well, I mean, I use different names and stuff like that, but no, mine didn't crash.
Are you running in debug? That doesn't seem to matter. Like it shouldn't crash, but it almost always does. Like I have never seen it not crash on these machines.
Now it's crashing. I wasn't running any Windows debugger.
So if you run debug, it crash? If you don't run debug, it doesn't.
No, I have a return statement.
Return where?
Return 0 if I wrong in
Does that help? No, if you run a debug, it still crashes.
I started without debugging, that's the difference.
What's that?
I started without debugging, that's the difference.
Yeah, if I do a control F5, it seems to work just fine. Maybe. Yeah. So that works if you're not running in debug mode. I'm not sure why it crashes in debug mode. What I'm going to show you though, we'll take a little break, but I'm going to show you how to deal with pointers, and that can also be used to deal with the strings. Now there's also another trick you can use with strings if you are having trouble with it crashing or not loading and saving properly. But we'll take 5 and come back and look at some of that. Okay, let's add a weapon to the hero here. Now the weapon will be constructed with default values, and that's fine. We just want to know if we can load it and save it, and if all of that still works. And we're using other objects inside of our class. So that should all be fine. For display down here, I'm just going to call weapon display. Inside the hero display. Right, because we've already written all of this. That will tell us if the weapon loaded up correctly. And if you wanted to here, you could even change weapon values. Just to see if that stuff works. All right, so I'm going to comment out the load. I'm just going to save this information. So run that. Nothing happens. We'll comment out the saving part and then uncomment the load. And we'll call load, and then we'll call display, and see how this works. Okay, so if you're doing debug, you should still get a crash. That's expected. But did it load my weapon? So it does load the weapon. The weapon does have the new values that I put in there, so that works just fine. So far, so good. Let's make the weapon a pointer. Okay, so it's not uncommon to have classes with pointers in them. And if we wanted to store the weapon and its information, it's just going to copy that address. And that's what I was telling you earlier. And that address is going to be something different when the program is ran at a later date. You can deceive yourself though. If you run this at the exact same time, like if we do this, and it saves that weapon there, and then we immediately load, and it goes and checks that address, nothing has changed. So it will look like it worked most of the time. And that's why I do this in two different steps. I'll run the program saving it, close the program, comment the save out, and then run it loading it. And that's going to give you a more accurate representation of what's really going on. All right, if this is going to be a pointer though, we'll have to make a few modifications in our constructor. Weapon equals new weapon. We'll have to allocate that memory. For good form, anytime you dynamically allocate memory in a constructor, you have to clean it up in the destructor. Don't forget that. Very, very important. Display, we can still call display. We'll have to use the arrow instead of the dot. And then down here in main, where we modify these values because weapon is a pointer, we'll change the dot to the arrow. And then change the value some too. So comment out the load. We're just going to save. And then switch it. Just going to load. See if I get the right values. And it did not load any of my weapon in. Right, this time it crashes at a different place. Access violation. Because when we saved it, we saved this address. We did not save what was at that address. So this is where you're going to have to do a lot more work when you want to load and save in binary form. Everybody understand why this didn't work? You understand what a pointer is, you understand that memory was somewhere else, and we only saved the address, so loading it back up, that object is no longer at that address. Okay, to make this work, we're going to move all of our loading and saving into the class. So below display here, you can write void save. We'll write a save method, and then we'll write a load method. And we'll work on saving first, because that's where our problem is. We don't want to save the address, we want to save the information at that address. So down in main, I'm going to copy these two lines, these three lines, or cut them rather, and paste that up here in the save. This is fine. This is a problem. Why is that a problem? Okay, and so it doesn't see hero because hero exists down here in main. What does this need to be?
Class name?
Hmm?
The class name?
No, not the class name.
Temporary object?
Not even temporary. We want to save the one we're working on. How do we get the object we're currently working on?
It needs to be a reference.
Somebody said it. This. I'm going to save this. We don't need the ampersand because this is already a pointer. It is already an address. And then the size of this dereferenced. It kind of flips on us. You can put the class name here, I believe, but I think it's safer to dereference this. That should definitely be correct. All right, and that way we can just call save on the object. And that takes care of that. Now, we still haven't addressed the issue of our pointer. So, before we close, we can write some more stuff in here. What should I put here? The weapon. We want to write, well, weapon's also a pointer, so I can just write weapon here. And the size of weapon dereferenced. And now instead of saving that address, I'm saving what is at that address. In theory, hopefully. And then we close the file. And we'll do something similar with load. So we'll take our in stream, our read, our close, cut those out of main, and paste them here. Same thing, we're working with this. I'm going to leave that the same. I'm going to leave that as size of hero. And then we also need to read in our weapon. What? So down here we can do hero 2, load. All right, we'll comment out the loading part and just run the save and see if the save works. It does. And then we'll flip the comments and see if it loads. I'm not doing this in debug, I'm doing this standard. I got nothing. Crashed where?
Crashes on the reading weapon.
for the sake of the video, I'm just going to scroll back over this. We're looking at the asteroids project, and I'm just going to roll over it. So if anyone needs to review, everything in main will be on the video. Draw bullets, we draw the player, we update the score. At the end here we have a collision checking function. And then we have the update score. Don't really need that anymore. Anybody need to see any specific part of this?
What if you have your update function for asteroid and thing?
Say that again?
I need your auto loop where you put the update asteroid, because I don't have that. I have the update asteroid and the check collision in the same loop.
Here?
Yeah.
I don't know that it needs to be in its own loop. In fact, I think in my Monday, Wednesday, Friday class, I do it in the same loop. But so yeah, I could do asteroid I update. Oh wait, is it dot? No, it should be arrow. Should be an arrow. Like that? Is that what you're saying?
Yeah.
Okay, that's fine. You can do it that way. I don't know why I put it in two separate loops. It should not matter. Let me verify it still works. Okay, that all works. Let's look at the split function and make sure that's correct. So take a look at your collision function down here. You should have a loop for all the bullets.
Yeah.
The vector of asteroids passed by reference. We update the score, we split, we set active to false. So let's go to split. If you don't know, you can hold down control and then click on that. It will take you there.
I changed my, when I'm passing in my asteroids is different. I was passing it by,
Here,
yeah, I passed it in by reference.
it should be the same. I mean, the address. Actually, I do it by reference on the other one, so if I don't think that matters. Let's make sure we're all on the same page here. You're doing that? Well, that's how I'm doing it in my other project. I ran this project parallel for the other class. So, I mean, in theory, you could do it either way, I think. Got it?
Yeah.
Okay, so let's move to split. And I said if it has not split 3 times, we're going to change the size. I did it by half here. I think 0.75 is better. We upped the split number. We created a new asteroid.
Does it ever delete the asteroids?
Hmm?
Is there anywhere to know where it deletes the asteroids?
Not on mine, not yet. We don't have that. We're going to put that in. Basically, this if statement is saying if it's split enough times, or if it hasn't split enough times, do all this stuff for the split, but then we're going to put an else in here that's going to handle that case that it needs to be destroyed. But just verify that you have all of this. We changed the size. We create a new asteroid if it splits. We set the values of the new asteroid, the position. We give it a random angle. And we add it to the vector. I think that's all good. You should have all of that, and that should give you the same behavior I had, where you can shoot these things and they just split, but they never disappear. Once they've split enough times, they're split out. And that's just it.
Mine worked fine at first until they got to a certain point, and then it crashed as soon as they entered the update, the asteroid update. And then every time I tried to run it after that, as soon as the bullets made contact, it crashes in the update.
Okay, I'll have to look at that one. But this is the behavior you should have. Does anybody have this?
I do now.
One person? All right, if you need to see a specific part of the code, we'll look at that, but let's put the else in. Okay, this is really bad, what I'm about to do with a vector. You don't want to erase from the middle of a vector. Remember, a vector is an array that you can grow. And it can also shrink, but if you shrink it, because it is an array, everything to the right of the element that you destroy has to be moved over. And if those elements are very big, that's a costly process. You know, you're wasting a lot of clock cycles just to shrink your array. And so a linked list would be much better here. But this still works, it still exists, and we can still do it this way, and we won't notice any hit to performance on a project this small, but just know this is frowned upon. Sorry, asteroid. What we're going to do is create an iterator. An iterator is just a fancy pointer. If you remember the linked list, we had a current pointer that was always pointing to whatever node we were working with. That's what an iterator is. And then we can use a library called algorithm. Now this is one that you want to at least be somewhat familiar with. The algorithm library has a lot of functions in it, and it's just called algorithm, no .h. It has a whole lot of functions in it, that are very useful, and that everything in here is highly optimized. So it's probably doing whatever it does the best way possible. And it has a find method. So after we create or a find function I should say, after we create our iterator, we can tell it to look through our vector of enemies and find a specific one. So we want to find, we're going to tell it where to start. That would be our asteroid. That's our vector dot begin. What did I call this? I called it A. So I was being lazy here. Whatever you passed in your vector as, that's what you want to reference. So A for me dot begin, and then we are going to the end of it, so A dot end. And so what this tells it is, hey, I want you to start at the beginning and look all the way to the end, and we're going to find a specific thing. What are we looking for? We're looking for the asteroid we want to destroy. What would that be called? What class are we in? Okay, so who are we looking for? You could think of it that way, but split count goes up inside here. Well, yeah, we're looking for the asteroid we just shot. And that would be this. And then once we've got it, we can do a dot erase. And you pass it the iterator, and it will erase that one. So we set up a pointer. We use the find method to find this asteroid somewhere in that vector, and then we erase it. And when we erase it, it's going to delete it. Actually, that's wrong. It does not delete it. It just removes that pointer from the vector because it's a vector of pointers, asteroid pointers. Erase is going to move, it's going to erase that pointer. It's going to move all the pointers to the right, or all the pointers that are right of that one to the left. So our array has all the elements in order, all next to each other like they're supposed to. But yeah, then we need to delete that asteroid so we don't have a memory leak. We can just delete this. Did everyone get that? So we understand our split function. If it has not split enough, we're going to do everything we did to split it. And then if it has split enough, we're going to get rid of it. We're going to erase its pointer from the vector, and then we're going to destroy that object. So let's see if that works. Seems to be working. If you have 4 asteroids, your score should be 6,000. All right, now before I help you guys that are stuck, I want to add a few more things in here. I said I would add at some point. In the player update, we had this really lousy function. This is the braking system right here, but this was bad because this is not time dependent. This will be different depending on what computer you're working on. So if you run this on a laptop, this might not be good. So to change that, we're going to say, I don't have minus equals overridden, so we'll just do it line by line. The x minus equals 1/2 of the velocity in the x direction times delta. And when we put delta in there, that makes it time dependent instead of computer processor dependent. And do the same thing for the y. 1/2 times velocity in the y times delta. That should give you a pretty good braking system that is consistent. It might give you smoother behavior overall. So yeah, it's different, but it's smoother, has a little more control. So you can try, if you don't like 0.5, try 0.7. The main thing is that delta is part of the equation. But that should be smoother. And it should be consistent across all of the computers. I think delta is supposed to be part of this. No, that didn't do anything. That broke it. So I'm going to change this up as well. I'm going to take these two lines out. And I think this will give us even smoother controls. And instead of, when we push up, instead of setting acceleration, we're going to set velocity. And that'll be based on speed times delta times the angle. I already have delta in there, never mind. So yeah, instead of acceleration, we'll just set velocity plus equals, and then speed times the angle times delta. Let's see if that is any better. That's a whole lot smoother. Well, what do you have your speed set at? That would be another thing to consider. So my speed's at 100. Maybe 400 is better. Or 500. We'll do 5. If you don't like it, you can change it back to what you had before, but for me, this is a whole lot smoother. A whole lot smoother. I like this. I have speed set to 500. And then in the player update, you know, I'm using this math instead of whatever I had there before. And I don't need this stuff. We don't really need acceleration vector. Normally 0.001. Delta is always changing.
Right. But is it?
Where do I set it?
Yeah. Where did you set it?
In main, at the beginning of the main loop. Not in the poll event, that's important. It cannot be in the poll event. But at the beginning of the main loop, you have these two lines that establish delta. And that normally produces about a 0.001. And there's a more complicated delta you can set up that runs on nanoseconds instead of milliseconds, and that can be good for really fast computers. So I'm thinking this is probably getting outdated, because if your delta is smaller than a float can maintain, then you get a delta of 0, and that's bad. All right, but that wraps it up, I think. We should have asteroids, you should have player movement, you should have splitting of the asteroids and the destruction of the asteroids. I did have, now these bullets on this version of the game are really fast for me, but I did have a bug in the other class that I found when I was calling reset on the bullet. I was not setting my timer to 0, and I think if you slow your bullets down, that causes them to disappear before they should. So here I think the timer should be set to 0. And then for more realistic gameplay, now it's fun to have a really powerful machine gun and all, but I think here's where I'm resetting it though. Maybe it was still working. That's a little bit different. That shouldn't hurt anything though, to reset the timer to 0. At 6,000, we're done. All right, so I'll go around the room and I'll help you guys, but for the lab, here's what you're going to be doing. You're going to be taking what you know about fonts, like we did for the score, and you're going to put in an FPS counter. That is not difficult, so don't overthink it. It's actually pretty simple, but I want to see the FPS. If your score's on the left, I want to see the FPS on the right, and vice versa. Next, you're going to save. We're going to reduce the asteroid count down to 2 initial, asteroids. And I want you to save the player, his position, his angle, all of his information, and all of the asteroids and their information to a binary file. So if the player presses Control S, it saves it. And if he presses Control L, it loads back in that game from that binary file. And be careful when you press Control S and Control L. If you do that, like we've done it here, if you handle that here in the player update, remember it's going to read this many, many times before your fingers come up off of those keys. And you don't want it to try to save or load that file hundreds of times. So you may need to put a little timer on there. You may want to handle the loading and saving in a different place, like the poll event, so that it only happens once. You get what I'm saying? You cannot press these keys quick enough for this to only happen once if you do it here. You don't want it to try and save and load hundreds of times. So keep that in mind. Make sure you have no memory leaks when you put in your loading and saving. All the memory needs to be accounted for. I've got it all written up, so I'll put that on Moodle, but there's a verbal overview of what you're going to be doing for your lab.